subject is structural analysis. Okay, so introduction chapter we required two concepts. One is support reactions, another one is number of equilibrium equations. Okay, so given support reactions, fixed support number of reactions are 3, for hinged support number of reactions 2, roller support 1, and vertical guided roller number of reactions are 2. What are the two reactions for vertical guided roller? That is horizontal reaction and moment reaction. For horizontal guided roller number of reactions are also 2, that is a vertical reaction and moment reaction. Okay, and I told one more point. If it is a link support, only one reaction. When it is called link support, if any reaction is perpendicular to the link and that reaction is 0, right? Next topic is number of equilibrium equations. Students, in GATE only numerical questions, no theory questions. Okay, so what are the concepts required to solve the numerical questions? I am going to revise those concepts. Okay, so second topic is number of equilibrium equations. Okay, I told most of students will do mistakes for beams only, right? Okay, for beams number of equilibrium equations are not constant. What the note point I given for beams? If the member is flat, okay, if the member is flat subjected to purely vertical load, then neglect horizontal reaction and horizontal equilibrium equation. Okay, so this is the note point only for beams, right? Don't apply this note for frames. Okay, I repeat, only for beams if the member is flat subjected to purely vertical load. Okay, so this is the flat member. So both are same diagrams. Okay, but this is a general load, right? I told if I won't show any load on the structure, which load is general load. So this is the general load. So for general load, fixed support number of reactions are 3. Okay, hinged support 2 and roller support 1. But students, and here number of equilibrium equations how many? Always 3. What are the 3? Sigma h equals to 0, sigma v equals to 0 and sigma m equals to 0. Okay, then if it is a purely vertical load, this is the flat member subjected to purely vertical load. I told neglect horizontal reaction and neglect horizontal equilibrium equation also. Okay, then here only 2 reactions. Neglect horizontal reaction. Here only one reaction and here only one reaction. Okay, so total number of reactions here 4. How many equilibrium equations? Only 2, that is sigma v and sigma m. Okay, so this is the most of students will do mistake here for beams. Okay, right. Then next I given equilibrium equation of a structure and equilibrium equation of a joint, right? Okay, for equilibrium equation of a structure, for a pin jointed plane frame, how many number of equilibrium equations? For structure, right? Okay, for structure number of equilibrium equations are 3 for pin jointed plane frame. Similarly, for pin jointed space frame, so no need to remember, actually not required for GATE. Okay, so it is 6, right? For pin jointed space frame number of equilibrium equations are 6. For example, just remember only 2, that is for pin jointed plane frame and rigid jointed plane frame, how many number of equilibrium equations. So to solve the numerical question we require only these 2. Okay, no need to remember for space frame. Next, for rigid jointed plane frame number of equilibrium equations are 3 only. What are the 3? Sigma fx, sigma fi and sigma m equals to 0. Next, for rigid jointed space frame 6. So students, in this topic you have to remember only 2 points. First point is for pin jointed space plane frame number of equilibrium equations are 3. For rigid jointed plane frame, number of equilibrium equations 3, always 3 for structure. Next topic I given equilibrium equation of a joint. Okay, equilibrium equation of a joint. So previous topic is equilibrium equation of a structure, right? Okay, then in joint again you have to remember only for plane frames, no need to remember for space frames. Okay, so for pin jointed plane frame, number of equilibrium equations are 2. Okay, what are the two? Sigma fx equals to 0, sigma fi equals to 0. Okay, similarly next for rigid jointed plane frame, number of equilibrium equations always 3 only. What are the 3? Sigma fx, sigma fi and sigma m equals to 0. So students, in this topic equilibrium equation of a joint, only 2 points you have to remember. What is the first point? For pin jointed plane frame and a rigid jointed plane frame, that's it. Don't waste your valuable time. Right, so these are the 2 topics you have to remember in introduction chapter. Okay, then second chapter is static indeterminacy. Okay, second chapter is static indeterminacy. So students, what is the general formula to find the static indeterminacy? ds equals to dse plus dsi, right? Okay, ds equals to dse plus dsi. What is dse? External indeterminacy. And dsi, internal indeterminacy. I told dse deals with support reactions and dsi deals with internal forces, that is member forces, nothing but axial force, shear force and bending moment. Okay, then students, how to find the dse? I given a few cases, right? What is the dse formula? It is r minus s only, right? Okay, so in first chapter I explained number of reactions and number of equilibrium equations. Okay, so if it is a beam, pin jointed plane frame, rigid jointed plane frame, DSE formula is same, that is r minus s only, where r is number of reactions and s is number of equilibrium equations. But while finding the number of reactions and equilibrium equations for beams, careful. So what is the note point you have to remember? If the member is flat, subjected to purely vertical load, neglect horizontal reaction and neglect horizontal equilibrium equation also, always. Okay, and for pin jointed frame and for rigid jointed frame, equilibrium equations always constant, it won't change. Okay, right. Then what is the DSI formula? But DSI formula is not same, right? It will change. Okay, so I told for beams, always DSI 0, right? Always DSI 0 for beams. Okay, then if DSI is 0, we can write the formula ds equals to directly r minus s only. This is for beams, yes or no? Okay, next for rigid jointed plane frame, for rigid jointed plane frame, what is the DSI formula? It is 3C, right? Okay, so what is this 3? Axial force, shear force and bending moment. And what is C? Number of cuts required to open a closed configuration or otherwise number of closed boxes. Okay, where C is number of closed boxes. Yes or no? So This is the formula to find the DSE and DSI, right? Okay, then for pin jointed plane frame, what is the DSI formula? For pin jointed plane frame. Okay, so DSI formula equals to m minus 2j minus 3, right? Okay, where m is number of members and j is number of joints. Okay, right. Now we can find the static indeterminacy. And what is the static indeterminacy formula for hybrid structure? What is hybrid structure? Combination of rigid and pin joints, right? Okay. So what is the general formula? DSE plus DSI minus force releases. So no, this is the formula, right, to find the static indeterminacy for hybrid structure. Okay. So for GATE exam, practice how to find the static indeterminacy for hybrid structure. Okay, expecting question from hybrid structure only. If we ask you to find the, if you give question from second chapter, that is from hybrid structure generally. Okay, so DSE, DSI as usual, same formulas, then only force releases. Okay, so here force releases. For moment hinge, how many force releases? Okay, for moment hinge, force releases equals to m minus 1, right, where m is number of members meeting at this hinge. Okay, then next, if it is a axial hinge, now this is the axial hinge, right? I told axial hinge we can represent like this also. So both are same only. For axial hinge, how many force releases? Only one, right? Force releases equals to 1. What is 1? That is axial force. Okay. Then third one is shear hinge. This is a shear hinge, and the shear hinge we can represent like this also. Both are same. Okay. Then what are the force releases for shear hinge? Force releases means which force it cannot resist. Those forces we have to remove. Okay. So here only one, right? What is one? Shear force. Okay. Next, internal roller. So this is the internal roller, right? For internal roller, how many force releases? Force releases equals to 2. What are the two? Axial force and moment. It can resist only shear force, right? Okay. Then one more is internal link. This is the link. Okay. Students, if it is a general loading, for general load, how many force releases? Force releases equals to 2, right, for general load. What are the two force releases? Shear force and bending moment. Okay. Then if it is a purely vertical load, for purely vertical load. Then how many force releases for purely vertical load? It is only one, right? So what is one? It is bending moment. Okay, so these concepts are required to find the static indeterminacy. Okay, so what are the concepts you required? Number of reactions, number of equilibrium equations, okay, and the next force releases. Then you can solve the any gate question. Okay, now I'll give one example here. Just I'll give few examples. If you find the static indeterminacy for this, then you can find the static indeterminacy for any structure. So one example, all the concepts. Right. Find the static indeterminacy for this diagram, then you can find the static indeterminacy for any diagram. So first we will find the number of reactions. How many reactions? Fixed support always 3, hinged support 2, roller support 1. Okay, then this is the horizontal guided roller, right? For horizontal guided roller, how many reactions here? It is 2. Okay, I'll give one more support. So this is the vertical guided roller, a number of reactions also 2. Okay, so I covered all the possible supports here. Okay, just count it total. So these are the total number of reactions. So I think number of reactions total is 10, right? Yes. Then how many equilibrium equations? Always 3. Then DSC equals to R minus S equals to 7. Okay. Then what is the DSI formula? 3C, right? Where C is a number of closed boxes. How many closed boxes? 1, 2 only, right? Equals to 6. Then force releases. Okay. So students, this is not the support. Okay, but this is support. Both are looking same. Most of students will think this is support. This is not the support. Okay, so this is in between the members, right? If it is in between the members, then it is nothing but internal hinge only. Okay, now this is the shear hinge. For shear hinge, how many force releases? For shear hinge, only one force releases. So better I'll change the color. So shear hinge, one force releases, that is shear force. It cannot resist shear force. Okay, and this is internal roller. For internal roller, two force releases, right? What are the two? Axial force and bending moment. Okay, and this is axial hinge. Axial hinge, how many force releases? Only one, that is axial force. And this is moment hinge, right? So moment hinge, M minus 1. How many members are meeting here? 1, 2, 3, 4. So 4 minus 1 equals to 3. Now these are the force releases. So total how many force releases? 1, 3, 4 and this is 7. Okay, then what is the final formula? ds equals to dse plus dsi minus force releases. You will get the answer. Okay, just substitute the values here. Okay, yeah, answer is 6 only. Now we will go to next chapter, okay, and important chapter, that is analysis of trusses. Okay, next chapter is analysis of trusses. So students, to analyze the trusses we have two methods, right? One is method of joint, another one is method of section. And before this I given three shortcuts. Okay, what the shortcuts I given? To identify the zero force members. Okay, to identify the zero force members I given shortcut, right? First shortcut I given for 3 members. Okay, at the pin joint, if number of members are 3, out of 3, 2 members are in collinear same line, then force in third member always 0. I told loads and reactions we have to treat as a members only, right? This is the first shortcut. How many members? For 3 members. And the second shortcut for how many members? 2 members, right? At the pin joint, if the number of members are 2, okay, but 2 members are in different line. At the pin joint, if number of members are 3, okay, out of 3, these 2 are collinear, then force in third member is 0. And if any external load is acting here, I told loads and reactions we will treat as a members. Okay, this is treat as a member. Now how many members are meeting? 3 members are meeting, right? Okay, and these 2 are collinear, then force in third member is 0. Okay, this is the first shortcut. For how many members? Only for 3 members. And the second shortcut, at the pin joint, if number of members are only 2, these 2 are same line or different line? Different line, then force in both the members are 0. Okay, and one more shortcut I given, third shortcut, but third shortcut may be zero force members or non-zero force members. Okay, but first 2 shortcuts for zero force members only, right? Then after this I given one note point. At the pin joint, if number of members are only 2, okay, and these 2 are collinear. Okay, these 2 are collinear. For example, if force in this member, if it is 10, then how to find the force in second member? No need to do analysis. Same magnitude, opposite direction, right? If it is right side, that is left side. Same magnitude but opposite direction. Okay. Then next I given pair of collinear, right? Now your number of members are meeting 4. Okay. These are pair of collinear. Okay, so students, these 2 are collinear and these 2 are collinear, nothing but pair of collinear. So for this case, force in this member if it is 0 and force in this member also 0. Okay, so force in this member downward 5, same magnitude but opposite direction 5. Okay, so this is collinear and this is pair of collinear. So these are the 3 shortcuts I given. Sir, last one. So in this last one, only 2 members are meeting. Okay, these 2 are collinear. If only 2 members are meeting, if these 2 are collinear, then what I am saying here, force in both the members are same. Okay, force in both the members are same, opposite direction. Okay, then here number of members are meeting 4. These two are same line, these two are same line. This is nothing but pair of collinear. Then force in this both the members always same but opposite direction, and force in these two members always same but opposite direction. Right. The students, I told in examination first we'll apply shortcuts. These are the shortcuts, right? If shortcuts are not possible, the next priority method of section. Okay, so we have two methods, right? Method of joint and method of section. When we'll prefer method of section? To find the force in few members, we'll prefer method of section. But to find the force in all the members, we'll prefer method of joint. But to get objective question, he won't ask you to find the force in all the members. He will ask you to find the force only in few members. So for this, for GATE exam, first apply these shortcuts. If shortcuts are not possible, then next try method of section. Okay, right. In method of section, we have to balance the structure or we have to balance the joint. In method of section, we have to balance the structure. Okay, it may be part of the structure or full structure. Okay, then in method of section, we'll balance the structure, right? Then here we have to use equilibrium equation of a structure. Okay, we have to use, I given in first chapter, equilibrium equation of a structure, equilibrium equation of a joint, right? Okay, so in method of section, we are balancing the structure. So this is the reason we have to use equilibrium equation of a structure. Then tell me, for a pin jointed plane frame, how many number of equilibrium equations? Always 3. What are the 3 equilibrium equations? Sigma h equals to 0, sigma v equals to 0 and sigma m equals to 0. Okay, the students, I told this method of section complete topic depend upon how to cut the structure. Okay, so I told you can cut the structure horizontally cut, vertically cut, incline cut, U, V, any zigzag shape. But 2 conditions must satisfy, right? What are the 2 conditions? Section should pass through selected member, first condition. Second condition, section should divide the entire structure into 2 separate parts. Okay, so students, I repeat, if you use method of section, this is completely depend upon only 2 conditions. In class notes, I given 5 star for this point, 5 star. Yes or no? Okay, so what is the first condition? Section should pass through selected member, first condition. Second condition, section should divide the entire structure into 2 separate parts. Okay, and to save the time in examination, I given preferable equilibrium equations. What are the preferable equilibrium equations I given? If I ask you to find the force in horizontal member, preferable equilibrium equations are sigma h equals to 0 and sigma m equals to 0. No need to use sigma v, waste of time in examination. And if I ask you to find the force in vertical member, okay, so if I ask you to find the force in horizontal member, preferable equilibrium equations are sigma h and sigma m. No need to try with sigma v, waste of time, it is not possible. Then if I ask you to find the force in vertical member, okay, so first try with sigma v, if it is not possible, next try with sigma m. Okay, so for vertical member, no need to try with sigma h, waste of time. Okay, and one more member, diagonal member or inclined member. Okay, so first try with sigma h equals to 0. If it is not possible, sigma v. If it is not possible, sigma m. Okay, so these are the preferable equilibrium equations. Okay, right. So this is the method of section. Okay, then method of joint, we have to balance the joint, right? So to balance the joint, we have to use equilibrium equation of a joint. Then for pin jointed plane frame, how many number of equilibrium equation for joint? Always 2. That is sigma h equals to 0 and sigma v equals to 0. There is no sigma m equals to 0 in method of joint. But for gate, remember shortcuts and method of section concept sufficient. Now we will see one question. Okay, I will cover all the concepts. Right. So this is the question given. Okay. So students, all the members of the planar truss, that is a plane truss shown in figure, have the same length L. Okay, all members has same length L and area also same. The inclined members are at 60 degrees with the horizontal. Inclined members, what are the inclined members here? So with the horizontal, this is 60 degrees with the horizontal. Okay, this is 60 degrees with the horizontal and this is 60 degrees with the horizontal. All the inclined members, but with respect to horizontal given. Okay, right. So this is the diagram and this is hinged support, this is also hinged support only, students. Okay, this is also hinged support. Right. Given there are 7 zero force members and option B, due to symmetry of the truss, force in member Fg and Eg are same and force in member Fe is W by root 3 and force in member Fe and Ag are different. This is the multi-selected question, MSQ. Right. Right, students, this is symmetrical or unsymmetrical? Symmetrical, right? Then due to symmetry, so anyway here 2 reactions, hinged support, right? Now this is He, this is Re, Rf and Hf. Okay, for hinged support number of reactions are 2. Right. So due to symmetry, total load divided by 2. What are the total downward forces? W, 2W, right? Then this is W. So all the downward forces equals to all the upward forces. So in option A, given number of zero force members are 7, right? Second shortcut I given. At joint B, how many members are meeting? 2, right? These 2 are same line or different line? These 2 are different line. Then force in both the members are 0, right? Second shortcut, just now explain. Okay. Similarly, at joint C, how many members are meeting? 2. And these 2 are same line or different line? Different line. Then force in both the members are 0. Okay, right. The students, in energy principle chapter, I given one more shortcut, energy principle chapter. Okay, students, this is a member Fe. Okay, member Fe. Tell me, for this member, which supports are there? For this member, hinged supports are there, right? Okay, I told if the member has hinged support at both ends and force in this member also 0. In which chapter I given this shortcut? In energy principle chapter I given this shortcut. Okay, if any member has hinged support at the both ends, okay, the students, there is no changing length of member, right, due to external load, because both are hinged support. This member won't allow to, this hinged support won't allow to increase the length of the member or decrease the length of member. Okay, then changing length is 0. If changing length is 0, strain is 0. If strain is 0, stress is 0. If stress is 0, force in this member also 0. So if both supports are hinged supports, if this member has hinges at both ends or not, then directly force in this member is 0. That's it. Right. Then next, so how many zero force members here? 1, 2, 3, 4, 5. Right. Then can you find the force in member FG once? Maybe force in other members also 0. Can you find the force in member FG? How to find the force in member FG? Shortcut, is it possible for member FG? Try shortcut at a joint F or at a joint G. Okay, I told force in member FG, force in member GF, both are same only, right? Because both are same members only. Okay, right. So what is the force in member FG? First shortcut, at a joint F, how many members are meeting? First shortcut, at a joint F, how many members are meeting? 1, 2, 3, 4, 5. I told we have to treat loads and reactions as a members. Now these two reactions we have to treat as a members only. Okay, now at a joint F, how many members are meeting total? 5. So there is no shortcut for 5 members. There is a shortcut only for 3 members, 2 members, 0 force members. Okay, so shortcut is not possible at joint F. Next, at a joint G, how many members are meeting? So these are the 0 force members, right? No need to consider. Remove the 0 force members. Okay, so 1, 2, 3, 4 members only. Okay, then 4 members, is it a pair of collinear? No, these two are same line, but these two are not same line, right? So we can't use the pair of collinear concept. Okay, then here shortcut is not possible. Then we have to use method of section. Then tell me students, how to cut the structure? Just I'll cut the structure like this. Okay, then we'll balance the left part of the structure. Only for left part cut members, initially assume tensile force. Only left part cut members. Students, you can do analysis for left part or right part, you will get the same answer, right? Okay, and you can assume compressive force also. I told you can assume always either compression or tension. Only for cut members only we have to assume tensile force. Just I am balancing the left part of the structure. This is the reason I assume tensile force only for left part members. Okay, right. Students, here we are finding the force in member FG, right? Okay, force in member FG are required. Okay, right. Now tell me 5 star. What is the first condition? This I want to find the force in member FG, right? Now this is the selected member. Tell me section is passing through member FG or not? Yes, first condition is satisfied. Second condition, this section dividing entire structure into 2 separate parts. Yes, now this is the left part and this is the right part. Okay, now 2 conditions are satisfied. Done. Okay, then after I told apply preferable equilibrium equations. What are the preferable equilibrium equation? We have to find the force in member FG, right? Member FG is inclined member. For inclined member, just now given preferable equilibrium equations, sigma h equals to 0, sigma v equals to 0 and sigma m equals to 0. Preferable equilibrium equations. Okay, so first we will apply sigma h equals to 0. Sigma h is nothing but horizontal, right? How many horizontal cut members are there? I told inclined cut member treat as a horizontal, vertical both. Okay, inclined cut member. Now this is the inclined cut member. This is treat as a horizontal cut member and vertical cut member both. Okay, so how many horizontal cut members are there? 1, 2, 3, 4. Now using one horizontal equilibrium equation, we can't find the 4 horizontal unknowns at a time. So sigma h is not possible. Next try with sigma v. how many vertical cut members are there? Vertical cut members 1, 2. So if it is only one, that is possible. So more than one, right? So not possible. Then sigma m, for moment equilibrium equation, which concept we have to follow? Wanted and unwanted member concept, right? Okay, so for moment equilibrium equation, always all the cut members do not meet at same joint, right? Only all the unwanted members should meet at same joint, and wanted member should not meet at that joint, right? Okay, right. Now sigma m possible or not, how to know? We have to find the force in this member, right? Fg. Now this is wanted member. Okay, Fg is wanted member. This is wanted member. Wanted member. And remaining cut members are unwanted members. Remaining cut members. What are the remaining cut members? 1, 2 and 3. So these are unwanted members. Okay, I told for moment equilibrium equation, all the unwanted members should meet at same joint, right? Now tell me, all the unwanted members are meeting at which joint? All the unwanted members. So no need to consider this one, because force in this member is 0. So forget about this member. Then how many unwanted members are there? Only 2. 1, 2. Okay. So sigma v. Okay, this is 0, right? Sigma v can apply, right? Yes or no? How many vertical cut members are there? 1, 2. But force in this member is 0. So directly you can use the sigma v, right? Yes. Now use sigma v equals to 0. All the downward forces equals to all the upward forces. We are balancing only left part. Okay. Now in left part, resolve it in vertical component. With respect to horizontal, this is 60 degrees, right? Okay. So resolve this in vertical, balance it vertical. So this is upward. Then force in member Fg. So vertical component is sin 60. Okay. Then what are the downward forces? In left part, this load is downward direction, right? Then this is W. So what is the force we got? And here there is a upward, this is upward. Okay. So there is a reaction, right? Upward, W. Okay. So this is upward and this also upward. Then what are the downward forces? W. Then W get cancelled. So what is the force in member Fg? 0. Okay. So force in member Fg we got 0. The students, because of symmetry, force in member Fg, force in member Eg both are same only, right? Due to symmetry, force in member Fg equals to and force in member Eg equals to 0. Now tell me students, how many zero force members total? So already we got 5, right? So 1, 2, 3, 4, 5. Now force in these two members also 0. So total number of zero force members are 7. Okay. Then option A is correct, right? Option A is correct. And due to symmetry of the truss, force in member Fg and Eg are same. Yes. Fg and Eg are same. So B also correct. Then force in member Fe is W by root 3. So students, What is the force in member FE we got? FE we got 0, right? Okay, but what is given? W by root 3. So this is wrong. Then force in members FE and AG are same. AG are given different. Okay, so we already calculated force in member FE, right? What is the force in member FE we got? 0. Okay, now we will find the force in member AG. Okay, find the force in member AG. So how to find the force in member AG? How to find the force in member AG? Same, cut like this, we got reaction is W, and we are balancing left part of the structure, and already we got these are the 0 force members. Okay, no need to consider. Now tell me how to find the force in member AG, horizontal member, right? Okay, right. Shortcut, is it possible for member AG? It is joint A. How many members are meeting? Forget about 0 force member. 1, 2, 3. But out of 3, 2 are collinear? No. Then it is joint G. How many members are meeting? I am not considering 0 force member, students. 1, 2, 3, 4. Okay. Then is it pair of collinear? No. These 2 are same line, but these 2 are not in same line. So we can't use the shortcut. Then method of section only. Okay. So in method of section, next, check it this section is possible or not. What is the first condition? Section is passing through member AG or not? Yes. And it dividing entire structure into 2 separate parts? Yes. So 5 star is satisfied. Next, preferable equilibrium equations. We have to find the force in member AG, horizontal member, right? For horizontal member, preferable equilibrium equations only sigma H equals to 0 and sigma M equals to 0. Okay, so first we will try with sigma H. How many horizontal cut members are there? 1, 2, 3. So more than 1, not possible. Then moment equilibrium equation. Wanted and unwanted member concept we have to follow. Okay, so which one is wanted member? We have to find the force in this member, right? Now this is wanted member. Okay, and remaining cut members are unwanted members. Now this is unwanted member and this is also unwanted member. And students, this is also unwanted member only, but force in this member is 0. No need to consider. Okay, no need to consider this one because it is 0. Then this also 0. No need to consider. Your wish. No need to consider this is. Okay, right. Then remaining only 2 cut members are there, right? If I remove the 0 force members, this is a one member and this is another member. I told for moment equilibrium equation, all the cut members should meet at, okay, all the cut members should not meet at same joint, right? Only all the unwanted members should meet at same joint, and at that joint wanted member should not meet. Okay, so student, this unwanted member meeting at joint, this joint, right? And wanted member, is it meeting at this joint? No, then sigma M is possible. Okay, so this is meeting at which joint? At a joint F. Now taking moment about joint F. So we are balancing left part of the structure. Okay, so in left part, students, this is the wanted member clockwise or anti-clockwise? This is clockwise, but we need this perpendicular distance. How to find this perpendicular distance, students? So this is 60 degrees, okay, and this length is L and this height is X. Okay, so how to find this one? Then here sin theta, that is sin 60 equals to, this is X by L, right, from this triangle. Okay, so from this what is x here? L into, then this is sin 60 is root 3 by 2. Okay, right. Now look at here. So this is clockwise, positive, force in member AG and perpendicular distance is root 3 by 2 into L. Okay, then next this is anti-clockwise, right? What the perpendicular distance? L by 2, right? Minus W into L by 2 equals to 0. Then from this equation, can you find the force in member AG? So 2 get cancel, then this is W by root 3. So force in member AG is W by root 3. So what are the options given? Force in member FE we got 0 and AG we got W by root 3. So what is given? Force in member members FE and AG are different. Yes, it is different only, not same. Okay, then what is the answer? A, B, D are correct. This is the answer.